According to the National Electrical Code, the device does not fulfill the requirements of a service disconnect. National Electrical Code Section 230.75 requires that the service disconnecting means also disconnects the grounded conductor, which the device does not. National Electrical Code Section 230.91 requires that the service disconnect be either a circuit breaker, a listed switch, or a fuse. The device is none of these. Several options exist for potential code proposal amendments. Option 1 is to amend National Electrical Code Section 230.70 to include the device as a service disconnecting means. This would require a new definition for the device and address the issue of the grounded conductor not being disconnected. Option 2 is to amend National Electrical Code Section 230.82 to include the device as an allowed additional service disconnecting means. This would also require a new definition for the device and specify the conditions under which it can be used as a service disconnecting means. Option 3 is to create a new section in Article 230 for the device. This would allow for defining the device and specifying the conditions under which it can be used. There are also additional considerations to make. These include Underwriters Laboratories listing. Underwriters Laboratories will need to create a new listing category for the device and local codes. Some local codes may have additional requirements for service disconnects. It is recommended to work with a qualified electrician or electrical engineer to develop a code proposal amendment. They can help ensure the proposal is technically sound and meets all the applicable requirements. The key code sections to consider are in Article 230 of the National Electrical Code, which covers service entrances. Specifically, Section 230.70, which generally requires means to disconnect all conductors in a building from the service entrance conductors, and Section 230.75, which addresses the disconnection of the grounded conductor. The device in question switches the ungrounded service conductors but does not switch the grounded conductor, nor does it provide any other means for disconnecting it. This is a critical point of non-compliance with the requirements for a service disconnect. In addition to these sections, Section 230.82 lists equipment allowed and the supply side of the service disconnect. Amendments to this section might be considered to accommodate the device, but this would require careful consideration of the device's function and safety features. Section 230.94 addresses the relative location of overcurrent devices and other service equipment, which could be relevant if the device is deemed to be service equipment but not a service disconnect. Section 230.72 covers the grouping of disconnects and could come into play if the device is considered an additional service disconnecting means. The design is based on interlocking breakers, typically a 200 amp service inlet and a 30 amp generator inlet. The generator is cord connected to the switch. The service input is routed from the lower meter stabs to the service inlet breaker. Dependent on breaker positions, the service or generator input is connected to the lower meter jaws in the existing meter base. The neutral or grounded conductor is not switched. The unit enclosure ground, generator neutral, and generator ground are bonded in the unit. A single connection is then made from this point to the grounded service conductor in the meter base. To further elaborate on potential code proposal amendments, let's break down each option. Firstly, amending 230.70 to include the device as a service disconnecting means would be a significant change to the National Electrical Code. It would require not just a definition, but a thorough evaluation of the device's safety and reliability. The main challenge is addressing the fact that the grounded conductor is not disconnected. One approach might be to argue that because the neutral and ground are bonded within the device, and because the generator neutral and ground are also bonded, the device effectively provides an equivalent level of safety as a traditional service disconnect. However, this argument would need to be supported by robust testing and engineering analysis to demonstrate that it meets or exceeds the safety standards of existing code requirements. Secondly, amending 230.82 to include the device as an allowed additional service disconnecting means could be a more practical approach. This section already allows for certain types of equipment to be installed in the supply side of the service disconnect. To include the device here, The amendment would need to specify the conditions under which it can be used. For example, it might be limited to use on optional standby systems, as defined in Article 702 of the National Electrical Code. It might also require that the device be installed in conjunction with a main service disconnect that does meet all the requirements of 230.70 and 230.75. This approach would acknowledge the device is not a primary service disconnect but can provide additional functionality and convenience in certain situations. Thirdly, creating a new section in Article 230 specifically for the device would provide the most flexibility. This would allow for a tailored set of requirements that address the unique features and limitations of the device. The new section could define the device, specify its permitted uses, and outline any necessary safety precautions. This approach would require a significant amount of work, as it would involve drafting a comprehensive set of regulations. However, it would also ensure that the device is properly regulated and that its use is consistent with the overall safety goals of the National Electrical Code. In addition to these code-related considerations, there are also practical and logistical issues to address. For example, the device must be easy to install and maintain. It must also be durable and able to withstand the harsh conditions of outdoor use. The device should be designed in such a way that it is difficult to tamper with or bypass its safety features. All of these factors will need to be taken into account when developing the final product. Considering the grounded conductor, or neutral, is not switched, careful engineering consideration must be given to maintaining the integrity of the neutral path. The device's design must ensure that the neutral connection remains robust and reliable under all operating conditions, including during generator use. This is critical for preventing voltage imbalances and ensuring the safe operation of electrical equipment connected to the system. Regarding bonding, the unit enclosure ground, generator neutral, and generator ground are bonded in the unit. This configuration aims to provide a solid grounding path for safety. However, it is essential to verify that this bonding arrangement complies with all applicable codes and standards, and that it does not create any unintended ground loops or other safety hazards. The single connection from this point to the grounded service conductor in the meter base must be properly sized and installed to ensure adequate grounding. The design should also account for the potential for corrosion or other environmental factors that could degrade the grounding connection over time. Furthermore, the device should be clearly labeled with all necessary warnings and instructions. Users must be informed of the device's limitations and the proper procedures for operating it safely. The labeling should also include information about the device's compliance with applicable codes and standards. To gain further insight into the code compliance issues, it may be helpful to review some specific sections of the National Electrical Code in more detail. For example, Section 230.66 covers the available fault current. The device should be designed to withstand the available fault current at the service entrance. This may require the use of surge protective devices or other measures to protect the device and connected equipment from damage. Section 230.71 addresses the maximum number of disconnects. This section limits the number of service disconnects that are permitted in a building. The device must be designed to comply with these limits, or else it must be installed in accordance with an exception to this rule. Section 230.85 covers emergency disconnects. While not directly applicable to the device, this section highlights the importance of having a readily accessible means of disconnecting power in emergency situations. The device should be designed to be easily accessible and operable, so that it can be quickly disconnected if necessary. In addition to the National Electrical Code, other codes and standards may also be relevant. For example, the National Fire Protection Association Standard 110 covers emergency and standby power systems. This standard provides requirements for the installation, maintenance, and testing of generators and other standby power equipment. The device should be designed to be compatible with these requirements so that it can be used safely and reliably in emergency power systems. The Institute of Electrical and Electronics Engineers Standard 1547 covers the interconnection of distributed resources with electric power systems. This standard provides requirements for the interconnection of generators and other distributed energy resources with the utility grid. While the device is not intended to be interconnected with the grid, it is important to be aware of this standard as it provides guidance in the safe and reliable operation of distributed generation equipment. The specific National Electrical Code requirements for optional standby systems, as referenced in Article 702, are also highly relevant. This article provides additional rules and guidelines for the installation of generators and other standby power sources in buildings. The device must be designed to comply with these requirements so that it can be used safely and effectively in optional standby systems. In summary, the code compliance of the meter socket transfer switch is a complex issue that requires careful consideration of numerous factors. The device does not meet the requirements for service disconnect, and therefore, it cannot be used as a primary service disconnect. However, it may be possible to amend the National Electrical Code to allow the device to be used as an additional service disconnecting means, or to create a new section in Article 230 specifically for the device. In addition to the National Electrical Code requirements, underwriters' laboratories listing and local codes must also be taken into account. The device should be designed to be safe, reliable, and easy to install and maintain. It should also be clearly labeled with all necessary warnings and instructions. It is recommended to work with a qualified electrician or electrical engineer to develop a code proposal amendment. They can help ensure the proposal is technically sound and meets all of the applicable requirements. The importance of involving a qualified electrician or electrical engineer in the development and implementation of the code proposal amendment cannot be overstated. These professionals possess the expertise and experience necessary to navigate the complex landscape of electrical codes and standards, and they can provide valuable insights into the potential challenges and opportunities associated with the device. They can also help to ensure that the proposal is technically sound and meets all of the applicable requirements, which is essential for gaining approval from the relevant authorities. Working with a qualified professional can also help to avoid costly mistakes and delays. By identifying potential problems early on, they can help to prevent the need for rework and ensure that the project stays on track. They can also provide guidance on the best way to address any code-related issues that may arise, which can save time and money in the long run. In addition to providing technical expertise, a qualified electrician or electrical engineer can also serve as a valuable advocate for the device. They can help to explain the device's benefits to code officials and other stakeholders, and they can work to build consensus around the proposed code changes. This can be particularly important if the device represents a significant departure from existing code requirements, as it may be necessary to overcome resistance from those who are unfamiliar with the technology.